89 or 88.
Okay. Let's say here I have two router connected with each other like this. Fine. Now to enable EIGRP on router, guys, command is very simple: router EIGRP and then network command. Like to enable EIGRP on router 1, we will run this command: router EIGRP and then autonomous system number. Now before starting EIGRP, we will discuss autonomous system number as well. Here we will run router EIGRP 100. Right? This is, let's say, autonomous system number. Okay, and then network command, network, let's say 12.1.1.0. This command will enable EIGRP on fast Ethernet 0/0. Right? This command will enable, this network command will enable EIGRP on fast Ethernet 0/0 because this network is running on fast Ethernet 0/0. Between router 1 and router 2, we are using this network. So network 12.1.1.0 will enable EIGRP on fast Ethernet 0/0. Once we will enable EIGRP on this interface, first of all, router will join, or this interface will join one multicast group. Which multicast group? Which multicast group? 224.0.0.
5.
Not 5,
10.
10.
10.
It will join this multicast group, right? After that, it will start sending hello message from this interface. Like RIP, if I will talk about the RIP, so RIP will do what? Once we will enable RIP routing protocol here, let's say version 2, it will join multicast group and it will start sending update message from here. But EIGRP will send hello message. It will start sending hello message. Now question is, what is the use of this hello message? Hello message is used to discover neighbor. Router 1 is trying to discover neighbor on fast Ethernet 0/0. Right? Means it is trying to find any neighbor is there on fast Ethernet 0/0 or not. And after that, this message is periodic, like RIP update message. So periodic means hello message is periodic because this message is used for keep alive also. It router 1 will use hello message to check the neighbor is alive or not. Let's say with the help of this hello message, router 1 have discovered one neighbor, that my neighbor is let's say router 2 R2. So with the hello message, after some time it will check this neighbor is alive or not. Right? So this is periodic in nature. Hello message is periodic in nature. Okay, if I will talk about this hello message, at which layer router will generate this hello message? At layer 3, because it is an layer 3 protocol now, so it will generate at layer 3. Then there will be source address. At layer 3, it will add IP header. Inside the IP header, there will be source address. Source address will be the IP address of exit interface, that is 12.1.1.1, and destination IP 224.0.0.10. multicast address of
EIGRP.
EIGRP, right? And then protocol field. Okay. Okay, then protocol field, after that layer 2 information will be there. There is no layer 4 information. Right? Now before discussing and configuring EIGRP over here, let me make you understand the autonomous system first, because EIGRP works within autonomous system number. Means both routers should be in same AS, then only EIGRP will work. Let's say here we are running autonomous system 100, here we are running autonomous system 200, right? So these two routers will not become neighbor. So inside the hello message there will be AS number. Let's say router 1 is sending one hello message, and inside the hello message AS number is 100. When router 2 will send hello message, in their hello message AS number is 200. So both router will came to know that okay, I am receiving hello message, but AS number is not matching. Now question is, what is AS number? Can anyone explain, guys, what is AS number? Let's say I have one society. Let me talk about one society. Let's say this is one society. Name of this society is anything. Let's say XYZ society. It is an XYZ society. Few peoples are living in this society. Let's say Anikesh is there. Anikesh is living in this society. Raja is living in this society, and Vasava Raj is living in this society. Now, first of all, how I will came to know that these guys are living in this society? I will ask. Let's say I am asking to Vasava Raj. Vasava Raj, in which society do you live? He said, I am living in XYZ society. I will ask to Raja, in which society do you live? He said, I am living in XYZ society. I came to know that both are living in same society. In the same way, when I will ask to Anikesh, Anikesh will say, I am living in XYZ society. I came to know, I come to know that Anikesh is also living in same society, right? That means name of society identifying which people is living in which society, correct? Now in this society, whatever people are living, guys, rule regulation like water supply, timing or light bill regulation, like after 10 p.m. no one can enter in this society. This is one kind of rule. So whatever rule is of this society will be same for all the people who is living in this society, correct? Correct, guys? Rule will be same for all the people who is living in this society. In the same way, AS is nothing but AS is a domain. Like society is what? Society is a domain area. In the same way, autonomous system is nothing but a domain. AS is domain, where routing policy for all daughters will be same. Like here, rules and regulation for each people is same. Like that, routing policy means the behavior of selecting best path, right? Routing, taking forwarding decision. Hello, any question?
No question, no question.
Please mute yourself, getting some noise. Okay, so routing policy means here, let's say two router are there in this AS. So routing policy on both router will be same. Now how I will identify that both router belongs to same AS? So like society name, both router will have one AS number. Both router will have one AS number. Let's say this router have AS number 100, this router have AS number 100. That means both are living in same society. But if this router have AS number 200, means this router belongs to different autonomous system. Means maybe routing policy on this router is different, routing policy on this router is different, and routing policy on this router is different. Getting my point? So AS is nothing like, and this society can be managed by single person also, and can be managed by multiple person also. Like that, this autonomous system can be managed by single person also and managed by multiple person also. So most of the time in some books also you will see autonomous system is a network domain which controlled by a single administrator. No guys, this is incorrect. It means the router belongs to same autonomous system will have same routing policy, and that can be managed by a single administrator also and can be managed by a multiple administrator also. Okay, like in a company, let's say there are 10 routers, so definitely on those all routers routing policy will be same. Routing policy will be same. That means all router will be in same AS in a single autonomous system. So like a society, this is also a domain where two router or more router can be in one AS, one autonomous system, or can be 100 number of routers also, 200 number of routers also. But routing behavior or policy will be same if they belongs to single autonomous system. Like we have same rule and regulation for the people who is living in XYZ society. Is it clear? And if you are confused with routing policy term, so don't worry, in routing you are going to learn routing policy only. For now, just keep in mind that AS is nothing but a domain where routing policy on all routers will be same, and EIGRP works within AS. Within ES means, let's say here I have two router R1, R2, both are directly connected with each other, and this is my, let's say, R1, this is R2. When these router will send hello message, see, router 1 will send their hello message when we will enable EIGRP here on this interface, and when we will enable EIGRP on router number 2, router 2 will also share their hello message. In both hello message there will be AS number. So let's say here we are running AS number 10, here we are running AS number 10, here we are running AS number also 10, same AS number. So inside the hello message of both router, in this hello message also AS number will be 10, and inside this hello message also AS number will be 10. So both router is going to check that my AS number, when router 1 will receive hello message of router 2, it will check what is the AS number inside the hello message. If AS number inside the hello message and AS number configured on me is same, then only we can form neighborship. Otherwise we cannot form neighborship. This is first criteria of EIGRP neighborship. Done. So in this scenario, what I am going to do here, config t interface fast ethernet 0/0 no shut, and IP address is, let's say, 12.1.1.1 255.255.255.0 no shut exit, and router EIGRP AS number, let's say 10, I'm running EIGRP 10, and then network 12.1.1.0. This command will enable EIGRP on fast ethernet 0/0, and once I have run this command on router, you can see in the capturing it is start sending, this router have start sending hello message, hello message, hello message, hello message. Continuously it is sending hello message to discover neighbor. First hello message is used to discover neighbor, and if I will open any hello message, you can see this is hello message. Inside the hello message we have what? Autonomous system number. It is sharing their own autonomous system number, that my autonomous system number is 10. After that there are some more parameters like k values, but we will discuss about k values or rest thing in upcoming day. And then opcode. Opcode is used to identify which type of message it is. Like, remember the ARP message, ARP request message, ARP reply message, ICMP request message, ICMP reply message. We have type code. Like that we have opcode here. In ARP request message also we have opcode to identify it is a request message or reply message. So opcode number 5 is used for hello message. It is used for hello message. So opcode of hello message is 5, and here we have some more information, but there is no any network information. Hello message does not carry network information, right? It is not used to share. We will discuss types of messages in EIGRP. You will see there are multiple messages, and purpose of each message is different. Here we have also update message, which is used to share network information, but hello message is used to discover neighbor. So we have some parameter like AS number, so AS number must match. Then we have some k values, these k values should also match. Like by default router is using k1 and k3 value to calculate metric. We will discuss about this thing. So router 2 should also use same k values to calculate metric, then only it will form neighborship. So these are requirement of neighborship. After that, if you will check layer 3 information, so first of all, see protocol number is what? 88. So EIGRP uses protocol number 88, and destination IP address is 224.0.0.10. 224.0.0.10. Source address is 12.1.1.1. Okay. So what is happening here? Router 1 have encapsulate one hello message at layer 3, right? And the layer hello message, source IP is 12.1.1.1, destination IP is ये, this one multicast, and protocol value is 88. Correct? Okay, that is here. And on router number 2 also, now I am going to enable EIGRP. Now on router number 1, you can see router 1 is sending hello message, but it have not discover any neighbor. It have not discover any neighbor. Continuously it is sending hello message only. Its source is 12.1.1.1. Now once I will enable EIGRP on router number 2, router 2 will also share their hello message. It will also encapsulate one hello message. Let me do that. On router number 2, config T, interface fast ethernet 0/0, no set, and IP address is 12.1.1.2 to 255.255.255.0, and then router EIGRP AS number, let's say here I am running AS number 20. Okay, and then network 12.1.1.0. So this time see both router is sending hello message. In this hello message you can see source is 12.1.1.2, but EIGRP, there is no EIGRP neighborship between router 1 and router 2. How to verify EIGRP neighborship? So IP EIGRP neighbor, no one is neighbor. And router 1 is receiving hello message of router 2, but AS number is different. So first requirement of EIGRP neighborship is AS number should be match. AS number should be match. Debug IP EIGRP hello EIGRP debug EIGRP packets hello. See, sending hello message from fast ethernet 0/0, sending hello message from fast ethernet 0/0, but it have not discover any neighbor. Now on router number 2 I am going to correct it. On router number 2 I am going to remove EIGRP AS number 20, say no router EIGRP 20 and router EIGRP 10. This time I am going to configure same AS number and then network 12.1.1.0. Okay, and see the capturing. Now it have sent the update message. So until and unless EIGRP will not form neighborship, like RIP, it is not going to share update message. Correct? Okay guys, both router have exchanged their hello message, AS number matched, both router became neighbor, and here we have one log message as well. Dual is the dual algorithm. We will discuss about this algorithm later. And EIGRP IPv4 AS number 10 neighbor 12.1.1.1 fast ethernet 0/0 is up, new adjacency, and we can verify it also, like so IP EIGRP neighbor. So it's saying this time neighbor is 12.1.1.1. I'm running this command on router number 2. So it's saying my neighbor is 12.1.1.1. This is the IP address of router 1. On which interface? On fast ethernet 0/0. Hold on time is 12 seconds. Update time, uptime is 15 seconds. There is SRTT time, RTO time, queue count, and sequence number. We will discuss all later. What is SRTT time, RTO time, queue count, sequence number, everything. For now, just read these information only. This is sequence number, this H is sequence number 0, neighbor 12.1.1.1 on fast ethernet 0/0. It have discovered one neighbor. And guys, on router number 1 also, on all, let me disable the debugging. So IP EIGRP neighbor. So what happened here? Router 2 have also encapsulated their hello message. Inside the hello message, AS number was 10, source IP was 12.1.1.2, destination was same, protocol is same, right? This message, router 2 have sent this message to router 1 and router 1 have sent this message to router 2. right? Both have exchanged hello message. After exchanging hello message, you can see the next message. Next message is update message. Who have sent first update message? Router 2, because source is 12.1.1.2, and then we have sent the next update message 12.1.1.1, and after that acknowledgement. Who have sent this acknowledgement message? Router 2. And where is the acknowledgement of router 1? One acknowledgement is missing here. So sometime in Wireshark, when you are capturing the link between routers, sometime you will see some messages are missing. So here one hello message is, one acknowledgement message is missing. 12.2 have sent first update message, then 12.1 have sent this message, and in this update message it have sent their acknowledgement message with which message? Router 2 have sent hello message, so update message. Router 2 have sent first update message. It have sent update plus acknowledgement. This is update plus acknowledgement message. Let me tell you here what is happening. First, router 1 have sent hello message to router 2. Then router 2 have sent hello message to router 1. Hello. After that, router 2 have sent update message. Update message. After becoming neighbor, EIGRP will send update message to their neighbor only, right? Doesn't matter EIGRP is enabled on how many interfaces. If they have discovered the neighbor, then only it will send the update message. And then router 2 have 1 have sent update plus acknowledgement message to acknowledgement of update message to router 2, and then finally router 2 have sent acknowledgement message. Acknowledgement message is nothing but hello message with acknowledgement bits on. Done. Till here, any question?
Yeah, actually here in that hello message, it will say like that router ID only, right? Means that interface, that IP address, right?
IP address of exit interface, yes.
Yes, IP address. See in that update message, actually what it will try to say, like
In
I
update
have
message, it
updated
will
your
say network
router.
information. Let's say router 1 have 10 number of networks. So it will send all networks through update message. Let's say router 1 have directly connected, these are directly connected network, or router 1 is receiving from their neighbor, doesn't matter. But let's say router 1 have 10 number of networks. So it will send these all network information through update message. But in this update message, you will not found any network information because router 1 have not any network till now. And as I told you that it will routers in all routing protocols, routers will not include the local network in the update message. Like if router 1 is sending update message from fast ethernet 0/0, from fast ethernet 0/0, so in this update message it will not include 2L network. When router 2 will send update message from fast ethernet 0/0, it will not include 2L network. Let's say router 2 is sending the update message to their other neighbor. Let's say router 2 is connected with router number 3, and here when router 2 will send update message to router number 3, it will include 2L network, but it will not include 23 network. So routers never include local network in their update 23.1.1.0/24. So when router 2 will send update message to this neighbor, router number 3, it will include 2L number, when 2L network. When router 2 will send update message to router number 1, it will include 23 network. Or like this, if they have more network, they will share all network through update message. So update message is used to share network information. if I will talk about messages of EIGRP, so there are multiple types of messages like hello message, update message, query message, reply message, acknowledgement message. We'll discuss all messages one by one. But for now, hello message is used to discover neighbor and keep alive. And timer is 5 seconds. Hold on time is 15 seconds. Means after every 5 seconds, both router will send one hello message to their neighbor. And router will store that hello message for 15 seconds. Okay, and hello message here you see that hello message is sent on multicast address. Sometime hello message will be sent on unicast address also, like in case of a static neighborship. Here in EIGRP we can configure a static neighborship also. This is dynamic neighborship. This neighborship is dynamic in nature. Automatically both router have discovered their neighbor. We have not defined who is your neighbor. So in case of a static neighborship, the hello message will be unicast. Okay. Hmm? Clear? Basavaraj, tell me.
Yes, sir. Yes, sir. But you can you just again you can say that last sentence like unique cost.
No, no, don't focus on it. We'll discuss a static neighborship, then I will show you. I am telling you that EIGRP hello message will be sent on two types of address, multicast and unicast.
Yeah. Okay. Okay.
Okay, so can I move?
Sir, in practical, this is easier than RIP.
Configuration is similar now, like EIGR RIP.
Uh-huh.
Configuration is
Yeah.
similar, but
Sim-
here we have we'll have lots of concept. We
mhm.
need to understand lots of things here
Okay.
in EIGRP.
Okay.
Like there are multiple types of messages. In RIP, we have only two types of message, request and response. That's it.
Okay.
Okay. Now,
Sir,
yeah.
sir, well, I have one more doubt.
Mm-hmm.
So here, okay, in the configuration, when let's say you have configured a EAGRP in R1 and R2, and while configuring in the EAGRP, you have advertised the network 12.1.1.0. You have not given any subnet mask. That's a different doubt. But I just wanted to check, like, see, R1 and R2, they both are connected directly to each other, more like, back-to-back IPs. Let's say if it is 12.1.1.1 and here 12.1.2 or something. So in that case, what is the purpose of advertising this network in the EAGRP? Basically, if
To
let's say
enable EIGRP on interfaces.
okay, see, if in case we don't advertise any 12 dot network itself, and let it be right in 0/0 if it is 1.0, and then 0 slash here in R2 if it is 1.1, then EAGRP will not be established. I mean, they won't exchange routes.
No, no. Please explain the question again. What you
Okay,
are saying?
okay. So now, I mean, I'm just considering R1 and R2 alone, okay, not
Okay.
R3. So in R1, in 0/0, we have configured 12.1.1.0 IP and
Zero
scheduled,
IP.
okay, or 12.1.1.1. No problem, it's okay. And
12.1 na? Yes.
12.1, okay. Here in R2, 0/0, we have configured 12.2. Okay,
Okay.
so it is more like back-to-back IPs, which we usually form for the neighborship or whatever it is. So now, while configuring EAGRP, now what is
Mm-hmm.
the purpose of advertising this 12.0/24? Because it is more like back-to-back networks only, right? Let's say behind R1, let's say if we have some 10 dot network, 20 dot network, and 30 dot network, and then in R2 maybe 40, 50, 60, right? Then those networks, whatever we have behind an R1 and R2, if we advertise it in the AGRP, then it makes sense, because R2 will come to know about the networks that is behind R1 and vice versa.
Now here we can advertise network like this also, router EIGRP10, and we can run this command, network 12.1.1.1.
That's what. Sir. What is the purpose of advertising this network itself? Because it is more like a back-to-back IP, right?
Yeah, we should advertise this like this only. We should advertise like this only, but just we have finished the RIP routing protocol, and RIP we use network 12.1.1.0, so I don't want to make confuse, right? Like this also you can see this command is perfect working,
Okay,
right?
so in case if we don't advertise this 12 network at all in this EIGRP, you say that the neighborship will not be formed. Huh?
This command, with this command,
I mean, if at all, right, we don't run this command network, we don't
no,
advertise
no,
this network.
EIGRP will not enable, no? EIGRP will not enable on any interface. To enable EIGRP, we have to use network command. Through network command only we are advertising EIGRP on interfaces.
Okay.
The difference between this command and this command is, nothing is different. Difference is only when I am running this command, router is checking that this network is running on which interface. When I am running this network command, again it is checking this network is running on which interface, right? So this is exact IP address. We should provide exact IP address to enable the routing protocol on interface. Otherwise you can run network command also, we don't have problem, because we are not using any other subnet from this main network. Like let's say on router number 1 we have one more interface connected with other router. There I am running network 12.2.1.0 network. So this time if I will run network like 12.0.0.0, 12.0.0.0, it will enable EIGRP on both interface. Getting my point? Like here I have one router, let's say this one R1. Here IP address is 12.1.1.1. Here IP address is 12.1.2.1, let's say. Both are in different subnet. If I am running network 12.1.1.0, this command will enable RIP on this EIGRP on this interface. If I am running network 12.0.0.0, this command will enable EIGRP on both interface, this interface also and this interface also. Okay, and this command is similar like 12.1.1.1. Okay,
There
yes
is no
Raja,
need to give a wildcard mask in the
you,
network statement.
you should give wildcard mask.
It's must or
No, it in EIGRP it not must, in OSPF it must.
then the first command 12.1.1.0 means what it will take for the mask, subnet mask.
8 na,
Wildcard mask.
2
I'm asking the wildcard mask.
255.0.0.0.255.255.255, this one.
So depending on the class, it takes the wildcard.
Correct,
Okay.
correct.
Actually, it's not advertising in EHRP. The interface which is having this the IP will be enabled. The EHRP will be enabled. It won't advertise, right? In BGP only, it will advertise with the network statement.
Exactly.
And one more doubt. So now, when you are saying, right, you also told that we are advertising in interface. I mean 0/0 in interface 0/1, something like that. But usually the ERGRP is something that we normally run in the global configuration, right? Let's assume that in R1 we have 0/0. Okay, and in R1 0/0 we have configured this back to back. Maybe in R4 or something which we have connected to the same router. Okay, and let's take R2. Okay, because it has got connected to two different networks, right? So in R2, in F/0/0, okay, we are running 12 network, and then F/1/0 we are running 23 network. Okay, so now in the global configuration, we say okay, router EIGRP 100, and then let's say we advertise both the networks 12.1.1.0 and also 23.1.1.0. So now when we advertise both the networks in R2, okay, now the next scenario is that in R1, if we are going to run the same EIGRP, the same autonomous number 100, And then in F0/0, when we are configuring this, we are configuring this IP 12.1 something, then it will establish the EIGRP connection between R1 and R2, and then routes will exchange. So when R2 is exchanging the route, it will exchange, it will share 12 dot network and also 23 dot network, right?
It will not share 12 network. Local network, it will never include local network.
Okay, fine.
Like when it will send update message to router 1, it will not include 12 network. It will share this network only. And when it will share update message to router 3, it will not include this network. It will share 12 network.
So what it means is that in
Means
R2,
directly
whatever
connected
networks
network
that we
between.
are advertising in the EIGRP, that will be shared to the neighbor. So in that
Correct.
case, how is it dependent on the interface level?
Sorry?
Because whenever you used to say, right, we are running EIGRP in this interface, right? So that's why I slightly got confused when you say in the particular interface you are running EIGRP.
So yes, on particular interface we are running EIGRP now. What you are saying, please explain again. Here it will send update message to router 1 and router 2 from this interface and this interface. Why? Because on these two interface EIGRP is enabled.
So no, that's what.
What is your question?
No, you are again saying, right, it is enabled in interface level, right? So that's why I slightly got that.
So you are saying that EIGRP is enabled on network basis like that?
No, I'm asking, sir.
No, not network basis. See, if I want to enable EIGRP on both interface with single command, I can run network 0.0.0. With the network command, what is happening? Actually, router is checking that network is running on which interface, and it will enable EIGRP on that interface. That's it. When it is sending update message from the EIGRP enabled interface, it doesn't mean that it is, if it is including this network, means it is not interface basis. It is interface basis.
Okay, okay, sir.
So in router 2, we have to give network 12.1.1.0, network 23.1.1.0 to enable on both the interfaces.
Correct. Or 0.0.0.0 means don't match anything. Don't match a single bits.
Then
Enable EIGRP on all interface.
in all interfaces of the R2, if you want to enable EIGRP, we have to give 0.0.0.0.
Correct. Correct. Let's say I have one router here. One router, I have one interface here. Here I am running 10.1.1.1 IP. Here I am running 10.1.2.1 IP. Here I am running 10.2.1.1 IP. Here I am running 10.3.3.1 IP. So if I am running network 10.1.1.0, this command will enable EIGRP on this interface only. If I am running network 10.1.10.1.0.0, this command will enable EIGRP on this interface and this interface, because here you can see 8 bits is matching in these two network, right? And if I am running network 10.0.0.0, it will enable EIGRP on all interfaces, right?
We have to give
Clear?
a wildcard mask also, right? Here.
Yes, wildcard mask also, but here wildcard mask is not mandatory. See, on router I have run what command? Network 12.1.1.0, correct? Here, okay, let me show you on router number 2. Here I have run network 12.1.1.0 and show IP protocol. In show IP protocol, you can see. Why?
Because it's class A.
Because automatic summarization is disabled. So if router 2 have one more interface where we are running network 12.2.2.2.2 to 12.2.2.2, it will enable EIGRP on that interface also, because here we have not defined the wildcard mask. But what I will do, router EIGRP S number 10, no network 12.1.1.0, and this time I am going to say network 12.1.1.0 and wildcard mask 0.0.255. See the difference. So IP protocol. Getting my point? So this is the benefit of providing default wildcard mask with network. But I am just teaching you. I am not configuring EIGRP in real time. Getting my point? So first try to understand how to enable EIGRP, how many messages are there. We can discuss about wildcard mask also. Like we have option to provide wildcard mask. And if your subnetting concept is clear, I think these are very basic things. Okay, or what I can do, we have one more option also. Here I am going to say router EIGRP 10 and no network. This I am removing this network also, and I can give the exact ID, means 12.1.1.2 and 0.0.0. This command will also enable EIGRP on fast Ethernet 0/0. Getting my point? This command will also enable EIGRP. So IP EIGRP neighbor, you can see neighborship come up, and so IP protocol, and this time we are performing routing for this network /32. So with the help of network command, what we are doing, we are enabling EIGRP on interface. Got it? And by default automatic summarization is disabled. Let me discuss some point about EIGRP here. Like when I am running so IP protocol
Recording on.
command. Yeah. So first of all, see, routing protocol is EIGRP 10. Outgoing update filter list for all interfaces not set, for incoming also. Default network flagging, we'll discuss about it. And EIGRP protocol autonomous system number is 10. Metric it is using, EIGRP uses K values for the metric. K values are link properties. K values are link property like bandwidth, delay, load, reliability, MTU. Okay, so these are K values. So by default it uses K1 and K3. These two values are 1, 1. We can change it, right? We will discuss why by default it is using these two only. Also, what is the logic behind it? Then router ID. We have not defined any router ID, so automatically it have elect IP address as a router ID. In OSPF, I am going to make you understand how router elect router ID automatically. What is the process? What is the election process? Then distance. We have two distance here, two AD value in EIGRP. One is 90 and one is 170. One is for internal prefixes and 170 is for external prefixes like redistribution. In RIP, we redistribute static routes. So here if we are redistributing any other routing domain prefixes in EIGRP, it will other domain prefixes will come in EIGRP domain with AD value 170. Then how many maximum path it can how many maximum path this router can install in their routing table is 4. Maximum hop that is configured is 100, and we can configure it up to 255. We will discuss about the variance also. It is used for load balancing. Automatic summarization is by default disabled, and maximum path is 4. We are performing routing for this network, right? And distance. Okay, so these are the basic information about EIGRP. Okay, on router number 1 also and on router number 2 also. Here we are performing routing for this network, and on router number 1, if you will run this command, so IP protocol. So IP protocol. So here we are performing routing for C2 network. We have run actually 2 network command. So run section EIGRP. See here we have run 2 network command. One is 12.0.0.0 and one is 12.1.1.0. Okay. I'm going to remove one router EIGRP as number 10, and let's say no to this network command. Getting my point? And so IP EIGRP neighbor. Done. And now router 1 and router 2 is not exchanging any update message. Both router are exchanging only hello message. We can debug it to see, and otherwise we can check the capturing. You can see in the capturing it is exchanging only hello message. Until and unless change will not occur in the topology, it will not send update message. Fine. Now what I am going to do, on router number 1 I am going to create one loopback here. On router number 1 I am going to create one loopback, let's say 10.1.1.0/24 network. I am going to run this network on loopback interface, and I will advertise this network in EIGRP. So let me do this first. On router number 1, go to config t, interface loopback 1, IP address 10.1.1.1 and then router EIGRP ES number 10. And to enable EIGRP on loopback interface, what command I will run? Network command.
10.1.1.0
Correct.
255.
And now here you can see in the capturing, router 1 have sent one update message. In this update message, let me stop the capturing here. In this update message, it is sending network information. Which network information? 10.1.1.0. And with this network, there is some extra information like K values. What is the reliability? What is the load? What is the MTU? What is the bandwidth? What is the delay? Right? Prefix length. And guys, to form neighborship, you know, there is 3 requirement. One requirement is AS number must match. To form neighborship between these two router, AS number must match, K values must match, and subnet should also must match. Right? Sometime interviewer can ask you that if subnet is different, then can EIGRP neighborship will come up? So no. Okay. So in this update message, you have seen router 1 is sending this network information to router number 2, and rest thing is exactly same, like layer 2, 3 information, layer 2 information, those are exactly same. After that, what happened? Router 2 have sent one acknowledgement. Then router 2 have also sent one update message. Why this update message? What is the information inside this update message? Same network. Now can anyone tell me what is the solution of this in distance vector routing protocol?
Sir, come again. Hello.
Hello? Yes. Router 1 have sent update message to share this network information to router number 2. And router 2 is also sending this network information to router number 1. Here a split horizon is enabled. A split horizon is enabled. That means you can see in this update message, delay is what? Infinity. This is route poisoning.
Infinity. Yeah.
Yes. This is route poisoning. Okay. That means router 2 have confirmed to router number 1 that this prefix is available via you only. Correct. And then router 1 have sent acknowledgement. So what happened here, when I enable EIGRP on this interface, first of all router 1 will put this network in their topology table. As I told you, EIGRP maintain 3 table, means advanced distance vector routing protocol maintain 3 types of table. Neighbor table, which you have seen here, neighbor table. So IP EIGRP neighbor, so IP EIGRP neighbor. Second is topology table. So when you will advertise, when I have advertised this network in EIGRP, router first install this network in their topology table. So IP EIGRP topology. This is a command to check topology table. Inside the topology table, you can see there are 2 network. One is 12 and one is 10.1.1.0. Correct. And 12 is the common network between router 1 and router 2. Router 1 have one neighbor 12.1.1.2. So router 1 need to share this network information to their neighbor. That's why it have generated one update message. Router 2 have given acknowledgement message. Then router 2 have also sent same update message to router 1 with delay infinity. And then router 1 have give acknowledgement. This is the process. Is it clear?
So what is this, sir? This FD is something showing that number. What is it? What is the meaning of that FD?
FD is feasible distance.
Okay, feasible distance.
And why is it showing passive P?
Path P, passive. P stands for passive. You will understand this thing.
Oh,
Don't worry. There are two types of route in topology table: active and passive. If say, let's say 10 network will goes down, first router will put this network in active state. Then it will ask to their neighbor, do you have any alternate path? If it will give if it will receive negative reply message from the neighbor, then it will remove it. We'll discuss about this thing,
So
don't worry.
here passive is good, right?
Passive is good. Passive means topology is stable. Active means topology is not stable. Anything else?
the same thing will be there even if we enable any route reflector also. Huh?
Route reflector.
RR we normally use in enterprise.
BGP. In BGP.
Okay, not in EIGRP.
No, no.
Means that active state means that link is disabled, or how actually
No.
how it is?
Active state means I have sent the query message and I am waiting for reply message.
Oh, okay. Means one-way communication. Okay.
Any other query? P for passive, A for active, U for update, Q for query, R for reply, small r is this one, S is SIA state. Now you will understand SIA, what is SIA, right? What is query message, what is reply message. Automatically you will understood this, passive and active. This is not big deal. Can I move now? So from router number 2, on router number 2, so IP EIGRP topology. Here also you can see in the topology table 10.1.1.0 network is available, and state is what? Passive means this is stable. One successor is there for this network. If let's say router were to have more than one path available, so maybe that path is also good. So that time you will see router have two successor. Successor means best path. Feasible successor means backup path. FD means total distance from source to destination. See from here, FD for this network is what? 28160. This is total distance for this path for this network 12.1.1.0. Formula actually EIGRP uses one formula for metric calculation, that is 10 raised to power 7 upon list bandwidth plus total delay upon 10 and whole multiply by 256. This formula. So if I will talk about the bandwidth of this link, see here, bandwidth of this link is what? So interface fast Ethernet 0/0 include bytes. Bandwidth is this one. So in formula, let me put the, where is calculator? Ten to the power 7 means 10. 1, 2, 3, 4, 5, 6, 7 divided by bandwidth of link. As I told you, 10 to the power 7 upon list bandwidth. So bandwidth is 1, 2, 3, 4, 5. 5. So divided by 5. Divided by 1, 2, 3, 4, 5, 0. 100 plus total delay. So delay of this interface is 100 upon 10. So 100 upon 10 means 10 plus 10, 110 whole multiply by 256. You can see it is calculating same matrix, same value, yes or no? So this is formula to calculate FD. Okay. And whenever router 2 will send this prefix information, means 2L network, to their neighbor, it will send the bandwidth, delay, everything, and neighbor router will also calculate FD for this. Like if I will talk about this network, so who have advertised this network to router number 2? Router 1. So that means router 1 have sent bandwidth, delay, and router 2 have calculate this FD value. Router 2 have calculate this value. If you want to verify, what you can do here, so interface loopback 1, and we can say include bandwidth. So this is bandwidth. So here bandwidth is going to be this one. Let me put here 10 to the power 7 divided by this plus total delay. Delay of this link is, delay is 5000 divided by 10 and whole multiply by 256. Can anyone calculate this value? If you will calculate this value, you can see you will find this value here. Okay, this is whole multiply by 256. Whatever value you will get after the calculation, you will multiply that value with 256, and you will get this value here on router number 1. So IP EIGRP topology, this value, right? So what I can do, let me calculate it. Ten power 7, 1, 2, 3, 4, 5, 6, 2, 7 divided by 8, and how many 0? 2, 4, 6, 1, 2, 3, 4, 5, 6 zeros are there, plus 500 equal multiply by 256. See, I'm getting this value or not? Something like this, because here we have a value in point, so that's why value is varying, but like this we are getting. So EIGRP actually calculate FD with the help of this formula, 10 raised to power 7 upon least bandwidth plus total delay upon 10 whole multiply by 256. And after that, always keep in mind, EIGRP never advertise FD value in update. It will not advertise FD value. When router 1 will advertise this network 10.1.1.0/24 to router number 2, it will share some information like bandwidth. It will share bandwidth. It will share delay. It will share load. It will share reliability. It will share MTU. But by default, it is using only two value, bandwidth and delay. Bandwidth and delay, K1 and K3. K1 is bandwidth, K3 is delay. So here it will share this bandwidth. Bandwidth is 8, 1, 2, 3, 4, 5. 50 was there and delay was 5000. It will share delay 5000. Right? When router 2 will receive this network information, router 2 will compare bandwidth which is coming in update and bandwidth of my interface. Which one is lower? As I told you, lower bandwidth. So lower is coming in update. Okay, so it will use this bandwidth to calculate FD plus total delay of my interface and delay which is coming in update 5000, and delay of my interface is 100. 5000 to 100 divided by 10 whole multiply by 256, and it will calculate FD. Okay, and let's say someone else is also providing same network information to router number 2, means router 3 is also providing same network information. So it will compare from which side I am calculating least FD value. Let's say on router number 3 also we have configured the loopback 10.1.1.0/24, and here I have changed the bandwidth. Let me configure this scenario. Now on router number 2, see, router 2 have not two neighbor, so IP EIGRP neighbor, correct? And so IP EIGRP topology. Both neighbor is advertising this network 10.1.1.0/24, and from both side it is calculating equal FD. So how many successor are there? 2, because FD from both side is same. So it will perform load balancing. So IP route EIGRP. If router have two path in routing table, that means router is performing load balancing. And now on R3 I am going to change the bandwidth of loopback interface loopback 1, and let's say bandwidth. Okay, and now you can see on router number 2, so IP EIGRP topology. Now how many path is there? Only one, because this time it is calculating least FD value via router number 1 via 12.1.1.1. See, this is the FD. This is the FD which router 2 have calculate via 12.1.1.1. And if you want to check what is the FD it is calculating via router number 3, what you can do, you can down this neighbor interface F0/0, say shutdown, and so IP EIGRP topology. Now you can see from this side what metric FD it is calculating, this value. So which one is lower? Via router number 2. That's why it have installed best via router number 2. 0/0 no set. Should I discuss metric calculation also, guys? FD, it is easy. By the way, you can configure by yourself also, like formula is 2 to the 10 raised to 7 list bandwidth total delay 10 whole multiply by 256. If you want, I can calculate the FD on each router for a specific prefix. Till here is it clear? EIGRP.